images of a terminal window, which is called the notebook server, which is running at the back end. As long as you want your notebook to work, you need to keep this server running. So don't close this little window that opens. Let it be. The next window that opens is in your browser. Is this readable from the back?
Yeah. Yeah.
Okay. So now you see the what it has navigated to is my default root directory. The first thing I do is I first navigate to where my current notebooks are. So in this case, I'm going to navigate to the notebooks that I've created for this lecture, so which is this page. And I'll open the first notebook, which is here. In case you are starting from scratch and you want to create your own notebook, all you have to do is go to New, and in the drop-down menu, select Python 3. And when you do that, you get started with a brand new notebook. So in case you're creating your own Python code, just go to the window that opened in the notebooks, go to the New tab, do Python 3. Okay, so like you see, this notebook is currently untitled, so you need to name it, you need to save it, and do everything else with it. But let's just first concentrate on the notebook that I've already created. Now, Jupyter Notebooks, as we covered in the video lectures, is a web application which is used in creating, and most importantly, its advantages has been in sharing your code with others. Just because these notebooks allow you to integrate your code, your comments, and the text information, and visualizations in the same document or in the same UI is the greatest advantage. So that way you can share your code, the output of it, somebody can interact with it, change values and rerun it, upload the data, and that way they can have the same experience as you in running the code. So this has been a drastic change in the way the code has been shared, the introduction of these Jupyter Notebook as markdowns. Okay, so some of the things I wanted to cover here, since many of you are new to the Jupyter Notebook, is if you're completely your first time, I do recommend, like when you open a new notebook, go to the help, and in help there's a user interface tool here that's useful if you've never used it before, because it kind of walks you through the different components. Like, I'll not go over this because this you can do in your own time, but this is if this is useful for anybody who's never used Jupyter Notebooks before. All right. Some of the things that I want to cover here is that in this notebook that I've put up, you'll see I have a few cells which are actual code cells, and there are other cells which are text cells. And how do I define whether something is a code or a text is using this drop down. So if I am to create a new cell, I can create it either as a code or as a markdown. In markdown, it's just a text cell which has description about your code. And in the code, you actually have Python commands which get executed. So let's see, if I suppose I write 5 plus 3 here, and it's currently a markdown section, and I run it, the output is nothing. Because 5 plus 3 is not a code statement, it's just text. But if I go back to this cell and make it a code cell, and now if I do run, I get the output 8. So that's the difference between like a markdown cell versus a code cell. The other things that you need to get familiarized is with the menu here. Plus is used to add cells. And next is to use cut cells. Then this is copy, paste, going up and down cell values here, taking cells up and down. Then this is run. You've got different options for runs. You can run all cells. You can run only cells before. So let's quickly try for one of these. So for 5 plus 3, if I say run cell, it would run just this cell and stay on this cell. If I choose an option like run cells and select below, it would execute this and then move on to the next one. If I say run, if I go back to 5 plus 3, I do run cells and insert below, it will execute this particular cell and insert a new cell below. So it just matter of like what you're running and how you're moving through your notebooks. Most often, when we're working on this, we use the keyboard shortcuts because it's like every time going up to the menu and doing the same your thing. So at least for Mac, the shortcuts is just press Shift and return, and it will keep executing the next set of lines. All right, so that's. Do you have a question? Okay. The notebook. Okay, Sammy is going to give everybody time. So the first exercise for today is go to Canvas, download the lab exercise.zip, and execute notebooks 1, 2, and 3. That will make sure everybody is able to run Jupyter notebooks. Everybody is familiarized with the content in 1, 2, and 3. I'll give you 10 to 15 minutes to do that, and then I'll come back and review those notebooks. Each of the notebooks has some little exercises for you to do, which build upon the examples given in the notebook. You can do these individually or group up in pairs of two if you want to discuss and do them together. So notebook 1, 2, and 3. And yeah, please if anybody has any problem with setting up, just let us know. Yeah, so this will not open directly. So first you need to navigate through here. So go to the root and the download. And then yeah.
I just using his question as translation and listen to it too. And expect why does
Yes.
zero
Just remind me.
almost like it from the flow?
Yeah. Because I think that's the whole thing. It didn't deter me or yeah.
Huh. Okay, cool. Thanks.
Yeah, so first you have to unzip it. No. Double click it. It's not able to do that. Yeah, you can. It's in a download. I'm really Windows. No, el verbo conmigo sí se había. Okay, so now we have see this is it. Earlier we typed this Z file, now we will have it. So we what we used to open was the zip folder directly. So what we did is we dragged the zip folder and read to the downloads. So because it was not really creating a zip folder, it was just showing you. So that's why we physically need.
Keep going, draw the exercise until
Yeah,
we
so
come
let's
back
do,
together.
yes, let's do the first three notebooks because I need to touch upon one more point before we go to the fourth. Because fourth will be archiving, so we need to make sure we have the files in the same folder. So let's do first three, we will do those and then give you time to do the next.
Dr. Gupta. Oh, it's just a quick question. What is the one of the instructions says read patient's CSV from Mimic. Is the is that talking about the file that we worked with last class?
Yes.
Oh, do you know what Mimic stands for?
Mimic?
Yeah.
Yeah, I blanked out the full form right now, but let's open it here.
Okay.
It's the data set.
It's a term that we went over, right?
Yes, that's the
Okay.
data set. But I think you're on notebook 5, so I'll prompt you how to open it. If you're able to open it, that's great. All right, so looks like everybody has the Jupyter notebooks open. Um, let's review these together once. So I'm going to review the first three notebooks and then give you time for doing 4, 5, and 6 again. So if you've done the first three, I would suggest just let's go over some solutions together and then we can come back for the next step. All right, so let's quickly go over the first one. Um, like I said, this like a first standard statement. You print hello world in any programming language. I did it for C, we did it for Java, now we do it for Python, and next week we'll do it for R. So this is the first to say that you've executed something in a language when you printed hello world. So that's the first customary line we print. I just want to make sure I'm on unmute for the Zoom window.
You need to unmute yourself.
Alright, so now that we've done that, Shift Enter is the shortcut for executing cells both on Windows and Mac. We tried it out, so it works on Windows too. So the next statement is simple. We do number 1. This is called an assignment. If you've gone through the videos, I'm assigning the variable number 1, the value 4, and assigning the variable number 2, the value 5. Next, I'm printing each of these. I get an error here, and your first simple exercise was to fix this error. Anyone who wants to volunteer to say what's wrong here? Yeah, and what does that tell us about Python? It's case sensitive. Always remember that. That's one of the most common bugs that happen when you're coding. That when you define the variables, you either use capitalization or did not, and later on when you're trying to access them, you forget about the capitalization. Alright, so the simple fix for this is going to be I just replace it with number and it works. Then we introduce the Python objects. The type for 5 is int, type for 3.14 is float, type for true is bool. The other thing which will give us this value is false. Try a few options here. If I do false with all smalls, it's an error because that's not recognized as true and false. If I do this, what will be the output? Again, an error. So the only way that it recognizes it as a keyword if I do false or true. Alright. If I do type of hello, that's str, which is a short for string. Then we do something called typecasting, which is changing the type of an object. So I'm changing the float 4, so it becomes 4.0. And then if I convert anything which is non-zero to bool, then it becomes true. If it was 0, then it would become false. Alright. Any questions for the next three exercises? Okay. What is the output for the first one? Bool. Is any questions here? It goes through bool 3. It decides the value is going to be what? What's the output of this part? True. And the type for true is bool. Alright. If I typecast 3.14 to int, the output would be 3. If I typecast 3.94 to int, the output would be 3. So typecasting is not a rounding off. Typecasting is just ignoring everything after decimals. Alright. Next is strings. You just need to be careful whether you're writing the string as a variable or whether you're putting it in quotes. So if I do print double quote sentence, it will print the actual word sentence. And if I print sentence without the quotes, it will print the actual value. Output of type 5 would be string. Alright. So that's notebook 1. So hopefully everybody has done notebook 1, no questions on the exercises. Alright, let's go to notebook 2. Notebook 2 introduces numeric operators that are used in Python, and there's an order of precedence for these operators. So again, we start with basic arithmetic. Why we're doing again these concepts is when we do advanced data science, we need to write loops, we need to write data frames, and we need to see how these logic and how these precedences work to make sure that we're doing the correct computation. For example, if he's computing BMI of patients from height and weight, if you're computing different kind of lab values and measures, we need to understand how to write that logic in terms of the numerical operators. Alright. So again, these are simple. Any questions in any of these that I'm running, just stop me right away. Alright. What is the output for this statement here? Any questions on this part? So what's really happening? First, the inner, the value inside the inner brackets being executed. So int 8.3 first converts this value into 8. Int 2.7 gets converted to 2. So the the value that's computed is 8 divided by 2, and that's why the output is 4.
Is there a limit on the number of commas you can do?
In print,
Yeah.
I have not tried. Neither do you know. Is there a limit on the number of commas you can put on the print? I'm sure there's
No.
some kind of a limit, but it's nothing like 15, 20, 25, 30 will not. Okay. Next is write one Python instruction, divide 20 by 5, and then multiply the result by 2. Anybody who wants to volunteer to walk me how should I write this? What practice do I need to make sure I have?
I just bracket in 20 divided by 5.
In 1.
Yeah. So 20 divided by 5 close parentheses star 2.
Cool. Thank you. Again, just making sure everybody's comfortable with Python. Next, we create a variable height with value 4, we find that. We create a variable height with a small h. So these are two different variables. These are not the same variables in Python. Again, putting that in context. So when I assign one variable the value of another, its value changes to the value of the new variable. And then we just note the difference in the output of the next few statements. So over here, I just want to emphasize in your Jupyter notebooks, you can have an explicit print statement that prints out the value. But if you also put just the name of the variable, it outputs the value of that variable. But you'll see a difference on how these two outputs are shown. Over here, this is just your output pipe value that is being shown. And over here, since it's being printed, you don't have that output back here. That's the actual output of your notebook. So just note the difference in the way these two things are outputted. And the last, okay, so another thing to note here is if I write 4 and A here, it will print only the value of A and not 4. But if I print both, then all the values are printed. So what comes out in the output space is only the value of the last variable in the cell above. So if you want to print multiple values, you have to use explicit print statements. Again, just introducing the if function here. If you write else or in brackets anything that you want to learn more about in Python, just do that, and inline within your notebook you get all the different options for it. Assignment and expressions. These are again how I can assign it to the variable b gets assigned these two values, and then I multiply the value of a and b together, I get the value of c. String concatenation is again very, very useful when we use data frames in our pipeline, and when we want to combine columns or combine different values, we need to do a lot of string concatenations. So the operator in Python that is used for string concatenation is the plus sign. So you can always also almost think of it as addition of two strings together. Alright. Then, like plus sign is used to put together two strings, the multiplication sign is also used in a similar spirit. And if you do height into 3, it actually prints height 3 times. So it's kind of concatenating height 3 times. So even though plus and multiplications are numeric operators, they work on strings. Alright. What is the value of sentence here? Again, all you have to do is copy paste this part in which I'm asking what's the output, and then if you print sentence, the value is this. again a simple exercise and then quickly write the solution. I first assign a age value 20, then I create a text variable with the value my age is, and then I need to concatenate these. Again, in Python, there are n ways to achieve the same thing. I'm just doing one of them. You can do it in a different way. There is nothing right and wrong. So if I just do this much, it essentially concatenates and shows me this.
I got a quick question on the John
Yes.
example.
Yeah.
The quotation marks, I can't quite understand. The main part I understand, but in my head, something belongs to those quotation marks. Can you kind of help me understand what the I plus quotation mark plus main times 4 is?
Yes. So let's see. Easiest way to do this is, let's see what happens if we remove this. So that quotation marks were introducing a space.
Oh, I see. That is, got it.
So essentially I'm concatenating three strings here. Hi, blank space, and John. And over here, you could have done the same as hi, John, or I just use string to essentially concatenate the labels. Like I said, multiple ways to do the same thing, depending on your interpretation, nothing right or wrong. Alright, let's go to Python 3's notebook. The goal of this notebook is to introduce conditional statements, which are if, then, and else, loops, and functions. Again, three very important functionalities in writing advanced Python code. When you want to make your code modularized, logical, you need these things. So we talked about the if statements in the lecture videos also. Over here you'll see the first one is trying to, we have a logic of if, elif, and else. When we do R, we'll see how the logic remains the same, only how you implement it varies from language to language. So when we go to R, you'll see how the keywords change a little bit, the format changes a little bit, yet the logic remains the same. So if you know what your logic is, you just needed to map it to the syntax of that language. Okay. Over here, you'll see that I have one logic written to compute whether the body temperature is high or low, and then I kind of run it through all the different examples. So when I do this, why do I get less than normal? Even though my body temp values are these three.
They're all the same variable, and it's just like whatever moment source.
Yes. So what's the way I do it if I have to run it for all three? I have to copy paste and run this code 3 times. So I first run it for 100, then I run it for 98, and then I run it for 95. So hence we introduce something which is called functions. And functions, like we talked about in the lecture videos, are modules that you define in order to put your repetitive code in it, so that you don't have to repeat a certain line of code. So this is an example of a calculate square function in which I wrote one function which is called calculate square, and it takes the value 10. Square is computed 10 into 10 and returns the value here. So if I run it once, I get the value 100. If I calculate score again, I don't need to write the above line of code again. I just need to give it a different value. I get the square for the different number. So we define one function called calculate score that does a certain purpose or repeats a set of line of codes. I can pass arguments to it. It computes the value and returns to me the results. Any questions so far? Here I'm showing what the call parameters is. So in this case, we are passing the value 20. In this case, if there's already a value defined, then that's what's taken. So if I call the my function with the value USA, that's the value that gets printed. But if I call my function without any value, then the default value is taken. So the output is I'm in Canada. Now we're doing the same body temperature calculation that we did before. It's just that we put it in a function. So we don't need to repeat the code 3 times. And we can just call the function 3 times. And each time we'll have the output. Alright. Any questions about the calculate heart rate? Let me show you. So if any of you have not had this done, there is a solution for it. Simple function called calculate heart rate takes in a value, applies the logic of whether it's between 60 and 100, whether it's less than 60. If none of these two conditions are satisfied, then the only condition left is the value is greater than 100, and in which case the value is high. And you can repeat it for 50, 80, or 100 based on the value the output will be different. Okay. Next we run through loops. Loops are again useful for us to iterate over different objects. So over here, if I iterate from 1 to 10 using the range function, it iterates from 1 to 9. Just remember this small difference, because next week when we do R, you'll see how it's a little bit different in R, how the lower range value and the higher range value are used in loops. But in case of Python, if we say range 1 to 10, it runs from 1 to 10 minus 1, which is 9. So the first lower part of the range is inclusive, and the outer part of the range, which is 10, is not included. That's what works for Python. Okay. Introducing the break here, and then writing a loop to print only R numbers. Anybody who has a solution for this? Yeah.
For I, for space I, space in, space range, 0 to 10 or 0 to anything.
Yeah.
Colon, and if I percent, I use the percent, but I think there's multiple ways.
Okay.
Equals 1, colon, print I.
So anybody who did not get that, that's the solution. Thank you. Alright, so everybody done with notebook 1, 2, and 3? Questions, doubts? Alright, so let's move on to the next part, which is notebooks 4, 5, and 6. We think that you need to make sure, I think for notebook 5, I'm going to show it to you a little bit because you need that information. So in notebook 5, sorry, I think notebook 6. For notebook 6, we're going to use the mimic dataset and open the file from there. So you need to make sure that the mimic demo dataset folder that we downloaded 2 lectures back, I think, is in the same folder as where your notebook is running. If it is not, you can set the path here. So there are 2 ways to run this. One, either you move your files to the folder in which the notebooks exist, or you just set the absolute path from the notebook to that folder. That's the one step we'll work through in these next steps. So anybody who's not able to run those six, just raise your hand. The only thing we need to solve is get your files in the same folder. Alright, so I'll again give like 5 to 10 minutes to do this.
So I couldn't. I don't think I have the admissions.csv file.
Do you have other files?
I have this one, which was attached in the.
So that was that given from us for Canvas or?
That was given from Canvas.
Yeah. So with this, you'll have to download the Mimic demo database from the website.
Oh, okay.
Yeah, we don't have 13 to 20 CSV files, I think. It's on Google type demo dataset. And I think you need Mimic 3. Yeah. Scroll down to the bottom. Yeah.
Oh, I see. I
Yeah,
found
it's all there. So you just download everything, which would be ideal, or just a specific table if you just need that for the exercise.
Okay. Thank you. What was your name?
Nigel?
Nigel.
Yeah.
Oh, I recall that you gave me a comment for homework.
Oh, yeah.
Cool. Thank you. Alright. Do you ever like data manipulating with the file called admissions.csv in the previous lectures? Do you have the edited file by any chance? Like the final product of edited version? Is that all? Do you think that you could send it to me? Thank you so much.
I just went over this channel level.
Yeah,
Transfer
that is. Thank you.
This is what you got here. I tried
Yeah, it's the wrong address. So, so over here you have to set the back to where your thing is. Since if you're in the same folder as your mimic, all you need to do is leave it like dot slash and then copy paste the name of that folder. So what it was looking for was like going to that mimic folder, but we don't really have a folder which is mimic. So this is your folder. So now it is on there. So you need to set the file path to wherever your folder is. So if it would have been in downloads, it would have written dot slash, go back to downloads and in downloads there is folder. And the name of the folder has to be exactly where the file is. So this is the name of the folder.
Dot slash gives you out of
So dot slash is current directory, and from there navigate to. So since you're running the notebook here, this is your dot slash. Even dot slash is optional. So even if you remove dot slash, it will work because it takes it from the current directory.
Matt, have you sent me by any chance?
Yeah, up there.
Oh, it takes time. Cool. Thank you. No, thank you.
zip for this file. Since you created it from this notebook and you didn't specify a different file path, it was created within this directory. So just go to this. Yeah. Okay. So it works off your current directory unless you change the file path. Yeah.
So I changed the file path to what I thought was going to
So it won't go to the zip folder.
I need to extract it. Okay. Absolutely zero. We need to copy the file again.
If you extract in Windows, is it always like that? Because that's an issue I was having somewhere else too.
I don't think so. I think I can pull it out of the zip and then although this might take a while.
What happened?
This might take a while because it's pulling, it's copying and pasting. But I think
How much RAM you?
this is a Department of Medicine computer, so it is absolute garbage. Probably 4 gigs.
I think it's this way. Got it.
It's gonna. I might have just. I haven't been needing the email yet. I don't know, now that everything's downloaded over there, kind of maybe, but I do want a better computer.
Yeah.
Yeah, I
You
think
get
this
in
one.
touch with it.
Yeah.
Yes, I think.
Thanks.
What is that?
Yeah, so I'm actually helping
R.
and the
So
oldest
R is the
get along with that.
So when I'm opening, I need to tell them what mode I'm in.
Forward slash,
Whether it's write mode,
like,
whether it's read mode, or whether it's pen.
yeah, and
So if I open it in
says
write mode,
big
I can write in profile. If I open it in the read mode, which is R, then I just want to read the contents. So open is a generic
just the
function,
big
and based on which mode you want to open the file, you can do
is it
you can
just
execute
not
commands.
define file?
Yeah, that's it. The data? For looking into the files. Okay. Windows. So some people, when they're extracting it from a zip, it's not really extracting it from the zip. I haven't changed the file. Add file extension to it. You have no connection. So let's look at it. Give it a look. Even like what? Look at this keyboard. What do I even give it? Okay. So this is not the same code as this. How do you get that code? No, no. Yeah, just copy the path in here. And then move everything in between. Yeah, copy the path in there. Yeah, copy it. Okay, so now
Can you give directions before? So I moved it in the Python notebook because anyway, and it's still
So that's just a syntax problem. So if you're in Windows, if you're using a backslash, for an example, instead of adding each character in the same
just do it all together.
yeah, do it all together and just put a
Slash
sign.
versus an R.
Okay.
Yeah, that's what I usually do. But yeah, it's
Or just you could use a regular slash instead of putting the R.
so I would want to remove this right?
Mm-hmm.
No, it has to be the same folder as where you're running. So you're running it here, but your mimic is in desktop, right?
Yeah, you need to put that.
Where is it?
No, so why don't you just copy paste that string to like parentheses instead of saving
Yeah, but your notebooks you're running are not here.
Oh, that's
Yep.
Those are you open from somewhere else.
Put bar there.
So
so I don't need the variable. Okay.
Or let's
so you will
just
get
put
to
a
know that
file path
because
in
over
the
here
parentheses
when you're
with that
running the
layer
notebook
and
it
see if
becomes green.
that works instead of
So
copy
earlier
pasting
it
the
was
whole
not
thing.
green. So that means this one is not running.
So it's just erase everything in the parentheses and just type in file path, which is your variable. So you need to undo that presentation button. See if that also works. So you can just
Okay.
it's just that R.
Yeah.
With R.
Yes. Yeah. Index cases. Like whether it's a range function, but this is also essentially range from the lower thing, right? It goes to 1 minus. And you notice it doesn't really go to R. And that's when it's confusing, especially when you're moving a code from R to Python. You need to fix these things, otherwise it's a different logic. So yeah. Also, if anyone wants to take like a quick water break, restroom break, please feel free to. In about 5 to 6 minutes, we'll come back in the notebook 4, 5, and 6.
No. Yeah. I think we just have a problem with the CD read CSV because I think it's the file path is
Yeah.
problem.
Do you move the folder, the same folder, or where they're running it? I
Right.
can enable
But
screen sharing if you want to show.
I think this is info, but it's just weird because they're specifying the absolute file path, so it wouldn't be a problem if they're not doing scrolling through that. And then they're facing multiple network problems or fixing each of them.
So PD is not defined in
It's
the
just not like so I don't
Yeah.
believe that. So I told them that. First it was the syntax, so I think
Yeah, so I can stop sharing and enable screen sharing so you can just look at that thing.
okay.
Okay.
Oh, Nigel, can I get a help real quick?
Uh, Actually,
Break time.
can you ask Anita?
Okay.
I'm trying to help someone in some soon.
Okay, cool. Thank you. Okay, Dr. Gupta. So,
Call me Aditi.
Aditi,
Nobody calls you Dr.
I'm just used to. I call everyone doctors. So the instruction says read only top 100 rows from admission in a
Yeah.
data frame named admissions 100. I think it meant to save the top 100 rows.
Yes.
Yeah, right. So, um,
Yeah, I've tried to do a few different ways to see if I can get it to pull in. Sometimes it actually works before. Yeah, so whenever I run this, for some reason, it tells me that there is a syntax error on keyboard.
yes. So, um, I looked up like how I would save only the first 100 rows,
Yes.
and I thought this was the answer.
Yes.
And the instruction says display the first 10 lines of the data
Yeah.
frame using n rows. Um, but to me, n rows was a parameter in reading CSV, right? So I
Yeah, so
used it
the
here.
hint, that's fine. I think in the formatting, it became a hint for the second part. It was just a hint for the first part.
Okay.
Yeah, so you can use it anywhere. This is correct.
Oh,
Now you just run admissions 100.
would there be a way to print from at the same time as saving this admissions 100 variable?
Yeah, you can write admissions 100 here and then run.
Oh, yeah. I was kind of like thinking about like because I use enrows to display the first 10 lines, right?
The hint was for both the parts.
Oh,
Like to in order to create, you use arrows and not hint for the display part.
oh, they're all
Yeah, the hint
together.
was for the second. Yeah.
It isn't too
Either
problem.
way, either way it shows up in mine. If it on notebook is it's the second line.
Oh, I see.
So I think it's a difference between maybe Windows and Mac. If it works, it's a little different format. But what you're doing is correct.
Okay, thank you.
No, just put it in front of the patient's CSV. Yep, that's working.
How are you doing that?
What?
Oh, I was just
How
saying,
to
like,
use
how
the
are you doing
forward
that?
and the backslashes
Yeah,
are a little
that
bit
syntax error.
confusing
I'm
and
tired of
sometimes
it.
confusing
Did you
for
get the?
Our team
because
Oh yeah,
I always
truly.
think I always think
yeah, I think it's
You got that
better
protein
if
bar though.
yeah,
the form
probably over
slashes
for like
to
10
specify
minutes.
10 minutes.
Yeah.
so that you won't have to
Your digestive system would be
I burned
superhuman.
calories. It's like finally catching up with me.
Yeah.
Did you get the syntax error solved?
Yeah.
Cool.
Okay.
okay, should we just try it right now again? Even though, yeah, just comment down to two sentences.
Yeah, so in the set, it's not like increasing order. It just
Right,
like
right. Remove the R.
sets are almost first in, like first in, first out.
Yep.
So essentially, whenever you append something to add something to the set, it gets added in the end. Yeah.
Right, right.
Yeah.
So, yeah, I think you either didn't have the slash before the patient's.csv, or you kept the R after you changed it
Well,
into
that's
a
weird.
slash. Those kind of things could have messed up.
Usually set are not
But yeah,
ordered, so it doesn't really matter.
all right. Sounds
Because
good.
these are
Even though
not
if you need anything else,
ordered
but
because like if they were ordered or indexed, then you can have three at index 0 and 2. But since you can only have unique values, usually doesn't matter. The other thing that we check is if there's a logic on how they work. Yeah. It can also be different to see. Okay, so you first have done this. Okay, so it was already changed. Um, yeah, okay, let me quickly check that. place because it's just a collection. It's not indexed.
Maybe the same question. Why added it? It doesn't. It
Yeah.
just does.
Because it's just unordered set of elements, it would just
Just random.
yeah.
Yeah. Oh, so what you want to do is replace all of this alpha with your actual alpha. So first thing you do is close your patient since yeah, just try to let's see what it is. Okay. And situating that patient supposed to be there. Either you can remove that or remove that. Just do one. Just whatever. Yeah, that's yeah. And this Windows uses Express. So either you change everything or just leave it like that. And then just put bar and put yeah, so those are the choice. You can either bar or this or
Um, Aditi,
Yeah.
I think there's a um some errors in the instructions because the admissions excels that we work with doesn't have these columns.
It doesn't.
No, the
So let's go to this.
oh here.
Yeah. Go up. Go up. Okay. Let's look at here.
Hmm.
Oh, that's all the columns you have.
Yeah.
Okay. So now I get it. So this is notebook 6.
Yes. I could just like try to eliminate other columns.
Yeah, you
Yeah.
can do that, but I was trying to see how is that reflected. Maybe I have a different version.
Oh, admissions.
Yeah.
Mm-hmm. That could be a possibility.
Okay. Yeah, thanks for letting me know. I'll fix that. Yeah, you should just try. The idea was just for you to eliminate columns, so you can eliminate some different columns.
Okay, I'll do that. Thank you.
And just try to forget that. So you're doing mimic feed, right?
I asked a classmate Matt to because that day when we worked with the mimics dataset, my laptop power shut down. So it's the other friend who
Yeah.
worked with the file that sent it to me. So I'm working with his. But that seemed to be from the mimics dataset. Three.
Mimic 3?
Yes.
Okay, yeah. So if it's a 3, it should be the same one.
Mhm.
So this is mimic 3. And if we go to admission, it has all of these types, right? So you have the normal files. So just go to like Google Mimic 3 demo data set. You will come to this page. So just do Mimic 3 demo data set. You will come to this page, scroll down, and download a zip folder from here. Have the wrong file.
Yes, I can see that.
Yeah.
Um,
Yeah.
Admissions.csv.
Download the zip folder.
Oh, I used this one. See, it. Never mind. Never mind. I'm wrong. um, the whole thing.
Yes. Then just unzip it.
Uh-huh.
Move it to the folder where you're running the notebook.
Okay. I should have just used the original file.
Yeah.
I'll work with it. Thank you.
I don't know off the top of my head. Can you send me that file? Or the particular thing I could write to? Yeah. Mm-hmm. In the inbox? Alright, is everybody ready to review 4, 5, and 6? Actually, let's just do 7 also quickly. Um, any questions so far? Hopefully, all of you have been able to figure out the Mimic file and have the code running. We'll just review it together. Anybody still at the stage of trying to figure out how to run Notebook 6? Okay, that's great. Alright, so the Notebook 4 introduces the concept of reading and writing text files. So you note here the moment that so this is a folder in which all my notebooks are. And if you notice here, the moment I execute this statement, a new file gets created, which is sampletext.txt. It gets created in the same folder as where you're running your notebook from, unless you specify a path where it should be created. So yeah, so this is a simple open function call with what flags you open it, whether it's W, R, or A, kind of defines how the file would be used. And then this is the first line, there's the first line in it. And then the next thing we did was, how do you check the contents of the file that you just created? You can either use cat or type that we covered in the CLI. And the good thing about Python is you can actually write the cat command here. So you don't actually need to go to the CLI to write this. You can write it within your Python code. All right. Next is reading the file. Reading the file means I have to set the flag as R. When I'm doing the open command, so note the difference. Both are calling the open function. Over here the flag is write. Over here the flag is read. Then read lines reads all the lines in the file, and then we iterate over and print one of the lines, which is the first line of the file. If I loop this with this loop command that I've written here, then it will print all the lines. Alright, so the next task for everybody was to read the patients.csv from Mimic. We walked through this for everybody. Kind of you have to set the path where your patient.csv lives. For me, it lives in this folder, which is in the same folder as my notebooks. So I can write dot slash, which means my current directory, this folder and slash. So this is the file path to where to find my Linux files. And when I open, it string concatenates. So this is nothing but a simple string concatenation of this file path variable here and my file here. And when I run this, it reads all the files, file values. Note it just reads it as plain text. So when we go to the next notebook, we will see how to not read it as plain text, rather read it as in a data frame. But if we use the plain Python function of read lines, then it reads it as a text file and not really as a CSV or a data frame. So note the difference when we use the different command, but over here it's all text values. Next is our commands to um, write a new line in the file and then opening it. Finally, we read it. So you'll see that since we opened the file in the append mode, it added a new line here. But the line was added without any space and slash n because it's a text-based input. I just want to show, like, if you change this, add a slash n here, and say this is the third line, and now if I run it, this will should have. Oh, because it's just trying to be in the first line. I need to be organized to show that. Okay, so now all the different lines that I've been adding, because I did append multiple times, all of these get appended. Okay, so what's the output of this statement? We just write it out by adding the third line. And we'll read this one. Finally, the last one is an example of how you take a user input within the Jupyter notebook. So till now, we've been taking input via files, but this is how we interactively take an input from the user while running the Jupyter notebook. So over here, I can enter the height in meters, the random value here, and then press enter. And it's not going to make sense now, but whatever it is. So once I enter the value, it's able to compute it in runtime and then give me the VMI. So this is just an example to show how you can run it in real time. Let's go over notebook number 5. So notebook number 5 talks about lists and arrays. In the first one, I created a list which has 4 different values. Remember the index for this in Python goes from 0 to 3. Again, a difference to note when you're doing R, the index in R goes from 1 to, if this was R, the index would be 1, 2, 3, and 4. If this is Python, the index is 0, 1, 2, and 3. So it's a little bit different in the two languages. When we do, and we can, a list can have any type of object. So the first one was a list of integers. The second one is a list of strings. Then we define a new list. We can use the len function to compute the len. These are how the different index ranges work. In Python, again, remember the value goes from 0 to n minus 1. That's how the index works here. Again, in function, in keyword and not in keyword are very useful in case of list to see if element value belongs to a list or not. So you can do this by seeing that if a particular element exists in your list or not by just using this in keyword. Whichever is, this you must have noted by now, but just in case you haven't, anything which is a keyword of Python is highlighted in green in the Jupyter notebook. So when you have in and not in and if, all of these are Python keywords and not variables, right? So just a thing to note about Jupyter notebooks again. All right. Now I'm going to add, we're doing two different functions which are append and insert, which add values to your list. When you do append, it always adds in the end. When you do insert, you can define at what position you want to insert a value. So that's where insert function is used instead of append. Similarly, sets in Python are unordered lists. So they are not indexed, they are just a collection of values. Just like the sets in maths. Alright. Again, easy. Set any questions, doubts for this part. Um, and then the last part just shows how you can remove something. So I wanted to remove an element 6.8 from the set. I used a function called discard. So you just need to know what function name it is for what kind of operation. There are different set of function names for list and a different set of function names for sets. Again, useful when we do the data science pipeline. Alright, so with that, let's move into our notebook 6, which was on using an actual data set. And the first step here is for everybody to import a package. So still now, what we've been using in Python has been the standard functionalities available in Python. So far, we've not imported in a package with some functionality. So over here, I'm importing a package called pandas, and I'm putting it an alias name to it as PD. If you do not execute this line, like if I were to not execute this line and directly go to this statement, this is the error you get. Because so far, my Jupyter environment does not know what does PD stand for. So I need to first execute this line in which I'm importing the package pandas as PD. If you don't want to import it as PDs, you could have just used it as pandas. So first I'll execute this, and then I'll run the next statement, and it has ran. If I did not want to do this, you can also do this. Oh, so this would have worked too. It's just that I'm putting an alias to it, just because it's smaller for me to write. I don't have to write the full pandas every time. So that's how aliases work. Alright, so all of us work through how we need to set the paths. You always don't need to get your files to the same folder as where you're running the notebook. Just make sure the file path is correct. So you need to somehow direct it to where your files are or move your files to that position, whichever you prefer. Head commands. So again, once we have imported our admissions, this is a data frame that gets created. It's a pandas data frame. For short form, we'll just call it a data frame, which has the value that existed in admissions.csv. Head is a function within pandas that displays the first 5 rows of your data frame. So here, if you see, when I put admissions.head, it, it displays the first 5 rows. Note how the structuring of the data is different than when we use read lines. When we use read lines on patients.csv or admissions.csv, it read it as text. It did not import it directly to a data frame. When we use pandas and we read a CSV through that, it identifies what each of the different columns are, puts it in a data frame that is easily can be manipulated using the operations. So that's the benefit of using data frames. Alright. Next, there are multiple functions available for you to understand and get to know your data frame more. So shape function gives you how many rows and columns you have. So there are 129 rows and 19 columns in this admissions data frame. Len gives me the overall number of rows. Describe gives me the different values. So if I do describe, you'll see for each of the columns in my data frame, for each of the numeric columns, I get the different values. For example, what's the count, what's the mean value, what's the standard deviation, maximum, and other values. But note this works only for all the numeric columns because it won't make sense for us to compute maximum, minimum, and percentile values for non-numeric columns. Okay, info is another function which helps us, like these are some of the first steps that we do when we get a new data set. We import it in pandas and then we do info, describe and shape just to get a sense of what does my data have, like how many rows, how many columns, what kind of columns, what's the range of each of the column values. So these are some initial functions we use to get to know your data. So when you do info, it actually shows you for each of the columns what is the different, like how many of not null values exist, what's the count, what's the data type, so I know which of my columns are integers versus objects versus strings and other things. There could be date time here, so it kind of depends on what your data set has. Alright, so like we read admissions, the next task for you is to read patients on CSV. Does everybody was able to read patients on CSV? Same for manual admissions? Okay, good. Next, we wanted to see if this thing is supposed to be the next slide. Okay. Um, so, in the first part, we saw how we import the whole data frame. Sometimes the files that you get in real life are so big that you may not be able to import the whole file in your Jupyter Notebook at the same time. And you may want to get in or import only say the first 100 lines or first 1,000 lines to look at what your data set is and then later on take the decision of you want to import all the 1 million data entries in it or not. So for that, we use this function called nrows, which kind of takes in only selected values. So what we'll do is we'll use the same statement that we did earlier for admissions. We'll call it a new data frame called admissions 100 and we'll pass it a new parameter which says how many rows do we want to include. And now if we do admissions 100 shape, we'll see this has only 100 lines and not over 120 lines. So this is most often used when we get a new data. We don't want to overwhelm our system, import everything. We just like import at 100 lines, 1,000 lines, whichever is feasible. Look at the data and then decide what you want to do with the whole data set. Okay. Next, I wanted to cover how do you export out. So over here, if you'll see, I essentially created a trimmed version of our admissions file called admissions underscore 100. If I want to write it back, I can use the I can use the toCSV function, which almost does almost the opposite of read CSV. So read CSV is to import, and toCSV is to export. So when I do toCSV, and I run this, if you go to your working directory folder, you'll see a new file gets created here. So this is a new CSV which got exported out from my Jupyter notebook, which had the value in that data frame. So whatever is in this data frame gets exported to admissions underscore frames. So how many rows will this file have? 100. Alright. Next is to drop columns. Again, very useful when you're doing your analysis. You get a data, you're not interested in the 20, 100 columns that exist there because they're not useful for your analysis. You first remove them rather than keeping them on for your further analysis. So columns to drop just defines a list. Once you have that list defined, you can just remove the columns using the drop command in pandas. Now if I do shape, instead of 19, now I have 16. Is unique, again, is useful for you to identify which of the columns in your data frame are unique, which of them can be used as keys, and which can be used as indexes. All right. I can change the index. So just note the difference here. If I do admissions.head, currently the index for this data frame is the automatic index in Python, which is from 0, 1, 2, and 3, and 4. But I can change this index to be one of the unique columns. So this is the first output. Now let's execute this and do head again. And you see the hospital ID, admit ID column move from here to the index position. Yes.
Was the like a way the program determines whether a specific column is unique is by was it by like seeing whether all the values are different?
Yes. So
Okay.
if a column is unique, means that each row in that data frame has a unique value. So you cannot have duplicate values in that column for that for the two rows.
So if there's 1,000 rows but two same values in among these 1,000, then it's not unique.
Yes, it's not.
Okay, got it. Thank you.
Okay, then a little bit touch upon the LOC function. So LOC function works on your indexes. So now that I've set my index to be the hospital admit ID, if I do LOC 199207, it goes to my data frame, picks up the rows which has this, and displays me all the values in that. So that's how indexes are used. If I don't want the default 0, 1, 2, 3, 4 index because they don't make sense for my data, I want an index which is a value in my data set, then I can set that column as my index. So if it was unique patients, I could have set the patient ID, and that way whenever I want to refer to that row, I just need to index to that MRM ID. Okay. So that brings us to the last notebook. Hopefully some of you have done it. If not, let's run it together. This notebook actually replicates one of the exercises you did last week in Excel, which was creating a data profile. So we created the data profile using Excel. We'll do it today in Python, and next week we'll do it in R. So you'll see how to do the same task in 3 different ways. Again, the first task, import pandas. Next task, I'm going to import the file, that's exactly the same file as we used last time, which is patients puppy underscore clean. It already exists in your lab folder. So I read this file. After reading the file, I display the results. These are all the values in my file. The first thing that I do is I create a new data frame to create my data profile. So the data profile is a table in itself. So in order to create that table, I need to first define an empty data frame. So I'm defining an empty data frame using pd.dataFrame command. And once I do that, I create the first column in that data frame to be the patients.columns. What does patient.column have? Let's see. So if I just execute this part, which is patients.columns, it gives me the list of all columns. So essentially, I'm creating a column within my data profile to have this value, and that's my first column. Any questions so far? I created a new data frame called data profile, added a column to it, and the value in the column is the name of all the columns in my original data frame. Okay. Now I've shown one example at a time. So what if we want to add the row counts to all the column names? Now, in order to add the row counts, first I create an empty list. Again, there are n different ways to do this in Python. This is not the only way. You can create the data profile using different functions or different logic and different loops. I've done one of the ways to do it. First, I create an empty list of row counts. Then I iterate over all the columns and I append to this row count list the value of the patient's data frame for that column. Once I do that, I insert it in the data profile. So after I run this, so first when I created the data frame, which was an empty data frame, I added the first column to it, which had all the names of the column. Next, I iterated over all the columns to compute the row count, and I added that as the second column. Now I'm going to do something very similar. In addition to the row counts, I will add other things like distinct values. Distinct values is how many unique values exist in a data frame. Then null count means how many nulls are there. And then percentage null is how much percentage versus the whole data set. So when I run this and add this to my data profile, you'll see now I have a data profile, and the first column is the name of the column. The next column is the row count, next is distinct values, null values, and percentage null. Okay, and then the last step, I also wanted to show another functionality of the Jupyter notebooks. That once you run the code in Jupyter notebook, if you do want to download an original Python script of it, you can go to the file and you can say download as and select the py file. What this downloads to you is a standard Python notebook. This is a Python script that can be run on a terminal. If you see, all our markdown text is put as comments, and all the code that we have is as code. And then you can share this Python file also if you need it, or you can share the notebook directly. Alright, so I have a few minutes left. I'll let everybody run the notebook 7 because that's something you may not have run. It will also be useful for your homework because you build upon the data profile. 80% of the columns that you need for the homework I've shown here. I've left out 2 or 3 columns for you to Google and search on how to add those columns to your data profile. But 80% of those are covered here. So I'll let everybody run notebook 7, and me and Sarah and Nigel are going to be here. So if you have any questions, call us. And then anybody who has questions about their final project, like Tara said, we received a bunch of emails. You've read all of them, but we didn't reply individually because we were going to ask you to stay today and discuss on a case-by-case basis. So, and everybody who's done with someone can speak with me.
Aditi,
Yeah.
were you going to discuss? No, not discuss. There was an announcement today on Canvas that some of the significant questions that were asked about the final project will be addressed in the lab section.
Yes. So you're going to stay on from 6 to 7 to do that.
Okay.
Anybody has questions on notebook 7? Yeah.
How are you doing, Matt?
Awesome.
How are you doing?
Yeah. So is this in your downloads?
This is in my
Oh, there could be a code to do that, but Aditi just demonstrated to us that we just need to download
The
it.
other file is okay.
But there could be a code to download it as a Python.
Then let's go to terminal.
Most worries. She just went to file download Python. Python.
Yes. So our file is here. Now we can just do Python. Yeah, but that's how you execute it. You go to the terminal, navigate it to where your file is, and just say Python, the keyword, and the name of .py file that it executes.
Done for today, Aaron?
Yep.
Cool.
Have a good rest of your day, sir.
Have a good evening.
Yes, it's the same. Yeah, this is because somewhere in this, there's a value which is not important. There's an unknown value, there's a like a value. Because it doesn't so you can go in and replace, like replace all the unknowns by saying zero, and then contrast. Yeah, so you only need to do this contrast if it's needed. If it's not needed, it's fine. It works
I want to bring my laptop. To take notes. Can I sit here? So, first, I'll pull up the first assignment turn-in, which first proposed about the project. So I did get a like comment on. I have a so I got a feedback that I have a solid research topic, but some of the ones that I proposed includes computer vision, so this part is not possible. But I got a comment that the second research topic is good to try within this course's framework.
You could have done that,
So
or you could have done what you did, compute the number, if the number is same as the number of rows, then also it's good. So again, multiple ways to find out.
So there's actually a kind of bunch that I've written down. I'm gonna try to walk you through my interest, and maybe among them you might have like different view that something is possible, something is not possible, or you have some like data sets like websites already knowledgeable within your like know-hows. Okay, so this might not be unique, like a research topic. It could be already published. Yeah.
As long as you're not copying someone else, like downloading somebody else's pipeline, just saying this is what they do.
Okay. Cool. Two origins. Should I just tell you about the computer vision part as well, or just walk you through everything?
Sure.
Because maybe there is a data pipeline that among the ones that you're aware of that have already converted the computer vision to the textualized part.
Okay.
There could be. Like, I don't know. I'm interested in like so this is like the change of the total cerebral rate over the course of aging,
Okay.
and you can see kind of like a increasing curve to the age of around like 40s, and then every per decade the cerebral rate decreases 5%, um, 5% per decade. So I thought like this kind of a decrease in cerebral weight loss or in total brain maybe correlates to the section which the AD incidence rates start to boost, or such as like a double incidence rates. There could be some section. So maybe I thought if there's like a CT scan or MRI scan that takes like cross sectional of the brains, and then compiles it whole this matrix into like some kind of textualized form, and so then every like photo of this matrix can be the spatial information can be analyzed among the age varied healthy demographic brain and Alzheimer's patient brain. Then, so this purpose is to provide information for at-risk patients. Hey, we scanned your data, and looking at this matrix, we found that compared to the healthy brain of your age, your brain mass is a lot lesser or a lot more. So I could provide like what is it comment on you're at risk patient, you're a safe patient comparing to the healthy brain among the same age. Or the other thing is, given that the patient has, because every individual at the age of 10 or age of 12, 15 or 20s individually might have different like brain development. Like some people could be have like IQ of 160 and like grow with a bigger brain mass at like age of 15 or something. Some could have IQ of like 90, 100. So I thought maybe if the momentary of the brain mass observed does not have to do with 80 incidence rate increase, maybe given that the patient visits the hospital periodically, let's per se 5 years, every 5 years, then looking at this patient's past data and the current data, 5 years ago and the current data, there could be a derivative of a spatial information change. And given in this spatial information change, if this threshold increase is more than some kind of limit, then we could say, oh, hey, given this 5 years compares to the others, although your brain, let's say this, let's kind of create a case for the IQ of 160, and IQ 160, like looking at comparing with the healthy brain people, and with maybe a IQ of 100, and there's this patient of IQ of 160, right? This patient with IQ 160 growth aged like from birth to age of let's say 60 with much bigger brain mass. But let's say from age to 55 to 60, this person's spatial information suddenly decreased so much, but still the derivative is very large. And this age of 60, and comparing this healthy brains age of 60, although this person's brain mass is bigger than theirs, the derivative of the decrease within 5 years was much less. And maybe that has to do with increased AD incidence rate. That's the second one. And that's kind of a computer vision part, I think,
Yeah.
that Nigel talked about. The other thing is, I don't think this has to do with computer vision. I wanted to kind of explore the healthy brain aging of people, and healthy brain aging that seems to show the signs of adult elderly neurogenesis. And I believe that this method of, if I can find that specific elements that are seems to be signs of triggering, stimulating adult neurogenesis, then it could be a prevention factor to the AD disease. So those who have signs of so among this population of healthy brain aging, and if they can be differentiated, and if those data can that I can tell that these two are different categories, given the data set, which I cannot, I think I'm having a difficulty to find or explore. Given that within this population, among the ones that clearly shows the signs of neurogenesis, maybe if there's a past patient records among them, among those two who are showing neurogenesis, maybe there are those who have showed signs of brain size decay and then showed signs of neurogenesis, and there could be population of those who had continuously showed growth even in the elderly years. So comparing these aspects, I thought would be also helpful in especially for those who experience the brain decay and after that neurogenesis.
And
Yeah.
have you done this type of image analysis before?
No.
Okay.
Yeah, but I think like on this kind of approach for neurogenesis, maybe not. Maybe that's not like a kind of feasible, but maybe Alzheimer's have a kind of severity scale, right? Let's say that it can be scaled to 1 or 1 to 5, and 0 for the ones that don't have it. Those could be there could be people that are identified as score of 3 5 years ago, and after this and at the present time, suddenly becomes 0. I think that happens.
Yeah.
Yeah.
So, I mean, my initial thought is for purposes of this class,
Uh-huh.
I would keep it simple.
Okay.
So, you know that you can probably find an Alzheimer's data set somewhere. You could even use MB4. You could, request a set of patients with and without Alzheimer's and ask,
May I take notes while you speak?
yeah, and you could ask questions there. And I'm trying to send you the lessons. But I'm certain that there are other potential data sets related to Alzheimer's. But I would recommend looking for a general Alzheimer's data set for purposes of this course that you could start simple with. Ask a few questions, whatever you need. Look at feature determination. What types of clinical features could be used to predict Alzheimer's versus not.
Maybe don't use the brain mass.
Yeah, I mean, for purposes of this class, you might need to use,
Mhm.
basic clinical markers, diagnoses, I don't know what the predictors are for Alzheimer's. And I'm racking my brain here. We had a former student, like 3 years ago, who did image analysis for this project. I can only find out who that is because he did image analysis for this project. So at the very least, you can talk to him and get some ideas for how you can do image analysis. I think he worked with his own lab data, so I don't think it was a public data set that he was using. But at least he probably get some ideas for how to do that type of analysis on the three-dimensional imaging data.
Um, for feature determination, what do you think about EHR records?
I think that for purposes of this project, you should be able to find something.
Okay. Was there like a EHR record website that is recommended? That because if I like look for Alzheimer's database online, those are for specific patients that are diagnosed with it, but that doesn't involve the EHR records with it.
Right. So you have to use something like IGBT or like or I don't know if they would have quite the right data because it's an ICU database, so I don't know if that would be the right data.
Did you also recommend IGB2?
IGBT.
I2B2.
Um,
I remember MD clone was a fake synthetic dataset.
it's synthetic, but it's based off of the
Real
real
people.
WWC patient data.
Mhm.
So this would be like your first part, which is like data cleaning and script processes. So this can satisfy that part. You just have to do the first part of database modeling, and then the latter part of the actual little bit of advanced analytics and visualization. So the visualization, so this one comes under the descriptive statistical visualization because it's direct numerical values in each of these. The analysis visualizations would be to apply regression or clustering and all that. Then the results of that visualization.
So you didn't type in anyways. You just typed in this and MD clone, and it gave
So if
you
you use, yeah, so if you are using that, this data and this project, is your question about the HPC, so yes, so discuss or
So I guess the general method of finding, locating a dataset would be going into Google, searching Alzheimer's dataset.
I don't know what the turnaround time is for this one, but this one might be interesting source for you.
but that's like more of a comparison versus integrated with the data.
Maybe I'm not gonna like use the actual images. I think they'll take more than the rest of the time I have in this semester to learn. Because I personally look for Alzheimer's database too, but yeah, those things seems to have collected those like specific targeted patients with specific purpose, not really suited for big data that are like compiled with EHR records. And there were like, also like several other features that I was interested in. Was like number of family members living together, supplement drug they usually take, and doses of it. In general, lifestyle. The lifestyle itself could be diverged to many columns.
Right.
Diet, like habits, or sensory stimulants that they intake.
And that's all hard information to find.
Right, right. Yeah.
And then first 10 years of my life I was in school. So that's why I still think
So
but yeah,
seems
Canva
like
is
it's not gonna give you the
not
complete
used
list
by
of
80% of the
ATC.
companies.
So what if you ask for they want you to submit an application to get the data
Let
that
me, the data source that I'm thinking of, I'm really struggling to come up with what it is, like I can picture it. I think Alzheimer's is in there. Let me dig around a little bit and see. I think this one's a good place to start to see what data they've got. What you could potentially do with it. Because I remember for the class project, we really want, I mean, the minimum is a primary data set, so like if you had this type of a data set, and then enrich it with something something else. So, I mean, it could be as simple as applying one of the diagnosis classification structures to the diagnosis codes and showing that you can, roll your results up into different levels of granularity by type of Alzheimer's or type of comorbidity or something like that. It doesn't have to be, I've integrated these three different patient data sets to create this massive um, project. Just something to show realistically. You can integrate a couple of data sets, you can get the pipeline to work. That you'll have the framework there, you'll have the framework there, you'll have the pipes there, so that as you build out your research project, you can add to it. So you can add data to it, and it might be sort of alongside it, it might be fully integrated. But it doesn't have to be, your class project doesn't have to be some sort of novel, publishable research question.
Yeah.
And to be honest, we've had several of them come through this course that like, we didn't get any results that are meaningful. We're like, that's fine. You showed us you can run a regression model in Python. That's what we were looking for.
Mm.
It doesn't have to be something groundbreaking.
Um. Okay. So I think I kind of have a general gist on. Still, I think like even using these databases as we've addressed, like combining different information with this Alzheimer's that have been created with general purpose. I think I guess MD clone is the word ITB2. Those kind of data sets would be helpful, and I will look on this one as well. Also, like I also thought maybe because I remember from the course homeworks quizzes among many the recommended data sets included a lot of genomic data sets. Yes, yes, I have every one of them that are discussed in the quiz lectures saved. Uh, Everything of them, and maybe from here I thought if there can be kind of experiment data set um, that deals with in vitro mini brain models and that shows the output of how this mini brain model changes according to like electrical pharmacological or genetical stimulants. Are you aware of any data sets that may contain this information? Alzheimer's genomics. NIH it is.
If I would have, initialized this, so I'm keeping the value result equal to 1 outside my for loop.
Yeah, you don't
If
have
I
to like
put
recommend
inside my
anything,
for
but
loop,
I mean,
every time this will get reset to
search
1. So,
comes up with
so and if I
some
were to
different
set it to
things
something
depending
like
on
0,
what
then it
type of
would,
question you're
everything is
looking to
in 0.
ask.
So
This happens to
it's
be a
just
site that I was thinking about. So
yeah, a higher. So you just did
Sometimes I
initialization
kind of
okay,
think
this was an
maybe
iteration.
feeding a
When I had
question into a
presented
data
the
set is
adding
much
stuff that I
easier
was multiplying, I would have
than
initialized it to 0.
feeding a data set into a question.
well, that's part of the point is to, I mean, from a research domain standpoint, you want to look at
So it ends with a return.
genomics and Alzheimer's or neuroimaging and Alzheimer's.
Mhm.
That's your research domain. And then when building out your data science pipeline, that's where you want to be thinking. Like you want to be, it's good to have your specific questions in mind that you want to ask of the data because you want to make sure that you're able to answer those questions. But you want to collect information that you can ask more than just those questions you thought of. So you think of another question 6 months from now, ideally you already got the data set to work with, you just ask a different question. So you don't want to collect data that's so targeted for your question that if you ask a different question, you have to start over.
Okay. Keep a broad mind.
Yeah, from a data standpoint, but then as you're working on your analyses and your statistics that you're applying and visualizations in your results, that's when you want to sort of narrow it down to just like a pretty narrow research question, just as a proof of concept to show that your data pipeline is working.
Okay, I will. I will try. Yeah, I'm kind of like thinking a lot about this project, whether how I will turn out to be successful. Um,
And I'm sorry, can you remind me of your name so that I can send you that other reference as soon as I magically think of it?
oh yeah, please, that would be wonderful. Young Young Byum Cho.
Okay.
Yeah.
I'm gonna ask you to spell that for me. So that I also can you spell it?
Young G B as a boy EUM space bar and CHO.
Yep.
CHO. Yeah. And thank you so much, Tara, for your time.
Thursday, more time, let me things.
Okay, I guess I'll try to get going.
All right.
Okay. Have a nice evening.